All right, last section of the chapter. Here we go. We get to graph them. So I hope you all have calculators right now, because we're going to be comparing and contrasting different kinds. So Brant, do you have a calculator? Yeah? Oh, I see it. Cameron, you got a calculator? Yeah? All right. All right, so radical functions can be graphed. I'm just making a t-chart. You guys know this, right? And if I took away your calculator, that's the way you would do it. Okay. They can also be graphed as transformations. What's transformation mean? What's transformation mean? Caleb? I thought you were waving at me. No? You weren't waving at me? Who knows what transformation is? Okay, you were good until you said rotate. It's just moving. It's just moving. It up, down, rotation is one of them. Side to side is a translation. Reflection is a kind of transformation. Translation means back and forth or up and down. Okay, those are all kinds of transformation. Translation, reflection, rotation, stretch, and shrink are all transformations. Okay, so parent function. So in your y equals y1 right now, I just want you to put square root of x. That's going to stay your y1 throughout. Okay, I want you to just leave that there, and then we'll change it. We'll put stuff in y2 and graph them both at the same time. Okay, so I'm going to show you what the parent looks like. It should look something like this. Now, my window is smaller than yours. You probably have negative 10 to 10 on both, right? Okay, this is just, I would say this is negative 1 to what, 6? 1, 2, 3, 4, 5, yeah. So it's much more zoomed in, but you get the idea. Yes? Okay. Now, in your y2, go ahead and put this. Now, the important part is once you have the square root, you need to use the right arrow key, or you're going to put the square root of x plus 2 all in the same house. You don't want that. Right now, we just want x inside the radical, the plus 2 outside the radical. What happened to it, Key? It went up. Translated 2 units up. Is that right? Okay, so our domain and range, did the domain change at all? No, it's still all x's greater than or equal to 0, yes. Okay, when you need to get back to the standard window, you're going to go to zoom standard. Like 6. Okay. Zoom 6. Yes, sure. So our range, though, did change because it went up 2. So the lowest it is now is at 2 on the y-axis. Does that make sense? Yeah, easy so far? Okay, what happens if I put in, you can go ahead and change your y2 to x minus 1 now. Wait, before you do it, stop. What do we think is going to happen? You think it's going to move down? You think it's going to move to the left? Now you're changing it. You think it's going to turn to the right. Okay, so we've got down, right. Okay, so hopefully one of those is it. I'll say the right answer has been mentioned. It was, and she said all 3 of those things. Yeah. What happened? It's not working? Okay. We need to reset your calculator from yesterday. Remember, it was all messed up. Go ahead and get another one for now. I'll fix it. Yesterday was giving you fits. I bet you the deleting of some of the stuff you deleted. Okay, so what happened? It did. It moved 1 unit to the right. That's all that happened from the parent. Now, this was the example A or whatever. This is not the parent, right? The parent starts at 0, 0. But I don't have the parent on here, which I should. Should have put that one on black and you can see the colors. So all it did, the parent moved from 0 and it moved positive 1. Why? Why did it move? Why, when it's negative, why did it move positive 1? H's are hokey. Because you know, there it is. I did put on there. See, smart, I just forgot. There's our H's and K's. Okay, do you see a pattern? We know an absolute value that looks exactly like this, minus the radical has absolute value instead. We know quadratic, instead of the radical, we have parentheses with a square. Same thing applies to cubes, right? So if we can remember A, and then whatever's happening, x minus h, whatever function we're talking about, and then outside of that is the plus k. So h and k is what, though, in this? Because before h and k was the vertex, in a cube, h and k is the point of inflection, or where the wiggle happens. Okay? In a absolute value, it's the bottom of the v, or the vertex. So what is h and k in a square root? It is. It's the beginning. Woohoo! Raise your hand if you need more time. All right. So here's when our h's are positive, it's going to go to the right. When our h's are negative, we're going to go to the left. We all know this. Okay, but inside, remember the sign is different than what h actually is, right? K, positive goes up, negative goes down. Now, stretch or shrink. This is the A that's outside multiplied to the radical. Okay, so the shrink or stretch, remember they stretch or get fatter, just like the quadratics when they have a fraction. Okay, whole numbers make them skinny. All right, and then a reflection means if it's negative, it's just going to flip. So let's go and put just a negative parent in there. Put negative square root x and just see what it looks like. If you do that in both, what is it? It'll look like something else. It'll look like a cool shape. So you've got in y1 square root x and y2 negative square root x. What does it look like? Oh, you haven't put x. Not x times 1, just negative square root x. What happened? That's enough. What does it look like? What does that shape look like on you? A parabola, like a sideways parabola. Is that what you guys all got? Looks like a sideways parabola? That's because it really is. Do you realize when you take the square root of something, it's plus or minus, right? We've talked about that. Plus or minus comes out. Okay, so really, we're only being able to graph the positive answers. So it should look like a parabola. All right. First of all, what is the starting point of this one? Without graphing it, what's the starting point? Raise your hand. Daniel. Negative 3, 1. Now, does it have a shrink or stretch? Shrink. Shrink. Stretches are fractions. Does it reflect? Does it reflect? Eli? Yes, why? Eli, hello? Hi. You said yes, why? Can you hear me? Okay. Why did you say yes? Okay, yes. 50-50 chance, is that what it was? Okay, because there was a negative. The negative sign makes it reflect. So your domain is you're going to start with what's inside. And it's only because we said it starts at negative 3, doesn't it? Right? So doesn't that make sense? That's where our domain begins. If that's our starting point, the domain starts at -3. Everything bigger or equal to -3. The stretch in the graph is happening. We already know that. Stretch by 2. So there's our parent. 3 to the left and 1 up. Right? And reflect down. And it got fatter. Phew. Now, we're just going to plug it in our calculator, right? I don't want to see you. If you had to do this by hand, could you? Maybe plot some points. Yeah, start with that. That's really easy. And that's my final is in blue. So all those movements happened. Right? All those movements happened. Translation, reflection, stretch. Actually, but it looks like a stretch because of the sideways graph. All right. Does the order of the transformations matter?
Yes.
Yeah. It is like reverse PEMDAS is what it is. Just like when you solve. You guys realize that when you solve, you do all the adding and subtracting first, then you do all the multiplying and dividing to get away from that variable. Similar thing happens with graphing in order of transformations. Okay. Now, can I graph this? Can I graph that? Try it. See what happens. It graphs, doesn't it? What happened? It's going the other way. So it officially still has a reflection, it's just a different kind. Right? But when the A is negative, it always reflects up and down. This one's reflecting back and forth. Okay, across the y-axis instead of across the x-axis. That's important because that's new. We haven't talked about that before. This is the only kind of new part to parent functions we're adding on. Does everyone have that written down? Because it's kind of important. I would put a little star highlight that the negative x inside reflects across the y. Okay. What is 0.5 in a fraction? Yeah. So is that a stretch or a shrink? Yep. Okay. So if I go ahead and say my domain is still going to start at 0, but what's going to happen because of this? Yeah, it's not going to be greater than 0. It's going to be less than. It's going the other way. Are you with me? Okay. And we know it's going to go up or down? Up, it's positive. And we know, yeah, that it's going to have a little stretch or shrink. So it looks like that. Nope. Any questions on this? This isn't too bad, especially since y'all have your calculator. I'll let you use your technology throughout this whole thing. Okay? They assume you're not, but, you know, I know them. Okay. All right, that's it. You have a quiz tomorrow? No. Right? Easy breezy? Okay. So you should be able to get most of this done. It's a Wednesday. Let's just knock it out right now. Okay? What? And that's you.